Hello, my dear friends. In the last video, we left off at this point. In the second part, we just made a markup. I've just added male and female color in RGB triplets because we would need them if we want to perform linear interpolation on colors. Let's get back to our HTML. And here we see that we have a face, leg, and body. So for morphing, we need two paths, path A and path B. Path B. So this is our path A, and we would just rename it to path A. And we also need a path B. So for path B, let's get back to the DXT and grab that. So this is our path B destination path. We just right click and copy SVG code. Then we will get back to our coding. And here we would just paste this code. And we only need this path attribute in within the SVG. We don't need a whole SVG here. So we just paste it and we'll get back and give it a name of B. We also need one more path, which is the copy of A path because it's a starting point, and we will call this morph. This is actually the path which would be animating as we progress. So this is morph. And we also have to make sure one more thing that A and B are not visible because we only want to show the morph. So we would give it a fill of none to A and B. So this is now settled, and let's remove this empty SVG as well. Now this is the markup that we would need for this code. Let's get back to our scripting, and here we can see that we have this color male and color female. We also have to grab the remaining HTML elements. First of all, we have to get path A, which is which we can get from previous lecture A, then morph. We also have to grab face and legs, although these are not actually morphing, but we have to get them to give them color because their color would be interpolated from one end to another end. So uh, this is these are the elements that we need, and the starting colors we already have. Now let's start by specifying some fundamental functions. So our first fundamental function is going to be sample path. So what is the meaning of this function? It means that not sample path, sample points from path. So this function would require it would require a path attribute, which is a path element, and then it would also require samples, number of samples. So let's specify the number of samples. We have samples as we discussed in previous video. The more the samples, the better. So we would start by adding 1,000 samples. Also, let's specify more variables that we are going to need. So our duration should be like 900 milliseconds. Duration is in milliseconds, so it's a sweet spot. I have done some experiments, and this is a nice time. And also, we would need start time for our animation, but start time currently would be null. We don't specify it at this point. This would be calculated when the animation is running. Then we would also need a variable to control whether our animation is playing or not. So we would just define another variable called isMorphing, uh, and currently it's false. And then we would also need to define the last variable, which is called duration, direction, sorry, direction. So we would have to have a direction. One is forward, uh, and one for A to B, and minus one is from B to A. So this is forward and reverse direction. So because we have two buttons, so we have to specify the direction as well. Now let's write this function. We need sample points from path. So first of all, we would get we have to get the total length of path. So length we would just call it path length, and this would be path dot get total length. This is a JavaScript function which already gets it done for us. So we also need points. So this path length is basically what we have is currently available. So whatever this path has, the length it gets as this, and these are the points that we will need to extract from it. We would run this loop in 1,000 times or whatever the sample size we have specified, and we would divide each path into those samples, and we will sample points from that. So here we would define a point. A point is there is also a very nice function which is called get uh, point at length. So this function ensures that we get a point at a particular length. So we grab this point and then we do also need to return the points. So what this function does is iterates over the iterates from one end to another end of the path, and it just for whatever point we specify at the particular length, it will sample that and give return that point. So we will just we have to divide this by our we have to multiply this I by our path length so that it increments regularly, and then we would divide it by samples. So this will make sure that the path length is divided into equal parts, and I would make sure that they are incremented properly during the looping. So we would return those points, and we have to also push these points in the this point should be pushed, and we have to make sure that we get proper x and y coordinates from this point. So we would just push this point inside our points array, and we will get that. Now we have to get these paths as well. So we would get points from A, and sample. I think the more appropriate name is sample points from A, and we would just call this function, and then we will also get sample points from B. So we would pass in path A and B respectively. And then we also, first, as we have got the samples, we have to write a linear interpolation function, the lerpPoints. And this function will accept three parameters. First one is array A, the first array of points, then B is the second array of points, and T is the time. T is the basically the parameter which goes from 0 to 1, which makes sure that our interpolation works. So it's a very simple function. We just have to map this A, and then we would write an arrow function in JavaScript. And the parameters would be from A, we would get x1, y1, and also we would get an index of which currently which element of the array we are accessing, and we will get the points from those. And similarly, we would get similar x2 and y2 from B, and this would be B at that same position. Then we would return uh, the linearly interpolated point. So basically, this is the same formula we studied in last video. X2 minus x1 multiplied by t, similarly y2 minus 1 multiplied by t, and add the current position y1 or and x1. So this will linearly interpolate our points. Second function is the color. So this function will also accept three parameters, C1, C2, and P. So as we know that our color has three elements, so each element will return one channel. For example, this one is red channel, this one is green, and this one is blue channel. So for red channel, we would just simply say C0, that would be red, then G, then B. So, and we have to return an RGB triplet. So we would just append this in the string, and it will make sure that this is a proper RGB color. This is our lerp color. Now we would write the function. We would write our actual function, which is morphing. So we can morph. We would just call it morph, and there is also a timestamp in this function. And let's write this function. So for when we call this function, we have to have some basic things set up for us. So if we don't have a start time, we would just give it the timestamp. This means that at the first frame, we obviously have this start time as null. So this would be true, and we would get the first timestamp as our start time. Now we would set our t variable. So how would we calculate t? So let's calculate t here. T is equal to the same formula that we studied in previous slide. And also, so what we are doing here right now is we are getting the current timestamp, whatever the time has passed. Then we subtract the start time. This will give us time difference, and then we divide by total duration. So it would ensure that our t is from 0 to 1. And if t exceeds 1, it means the animation has finished, and it would be t is equal to 1. So we have made sure that this doesn't overflow. And now we would just we would add we would just calculate the progress. Progress basically t is the progress, but we have to make as we have direction in as well, so we have to count that. So we would just say let progress is equal to direction. We are making it conditional. If direction is 1, then it's t. Otherwise, it's 1 minus t. So this will make sure that our animation can work in both directions. Now we would just get interpolated points. So we will get linear interpolated points by calling our function sample points on A and B, and we also get interpolated color. There is one more thing that we have to do. We have to also add a utility function, which is called uh, we have to convert the points which are returned by points to paths. Basically, this will make sure that the points that were returned from interpolation are actually uh, actual commands of SVG which can be used. So first of all, we have to have a command called m. Then we have to add this path strings will take the points as the parameters. So then we will have points points mapped as well. So we would just use this expression to make a path string. So what this does is this m means move to a particular point, and then we iterate over all the points, and we just make these points separated by a comma. Then at the end we append L, which means L means line segment. So all the points are basically becoming small line segments. And after we have done with all the points, we give it terminating point, which is end of the one, which is called Z. So this will make sure that all the points that we are getting are actual path strings that we can use in SVG. So just like here, we have a path string here which starts with M, and it has certain commands. So it will make sure that SVG understands what is the path that it has to render. Now we will just call we will get path string, and we will call our function. So we have all the attributes that we need. Now we can just set the properties. So we would just set the morph's attribute path string. Then we would set the color of fill of face, and then we also have to set morph. And there is also a problem here. We cannot name this our function as morph because we are already a variable with the same name. So we will call morph path, so that it is different. Now, this is pretty much all the things that we need to do. Now we also have to make sure that we terminate it properly. If t is less than 1, it means the animation should progress. So we would just call this function again and again. And when it's over, we would also need to set something, some variables. So let's first of all, there is also we also need to write another helper function, which we will call from button click. So we will call this button call mod. So it won't accept any parameters, but it would say if is morphing true is false, then make the it true. Then we will also set the start time as null, so that whenever we have a button click, we make sure that we are setting the start time properly. And we also have to make sure that male and female buttons are disabled at this during this animation is playing. Now we are just have to reverse this process in we just have to reverse these in our if our animation is over. So we will just set them to false. And one more thing that we have to call this function here, we would call morphPath. And we also have to make sure we give it the direction because it's very important. So from if we click on male button, it means that we have to move from female paths to male path. So its direction should be reverse. And similarly, we will call these two functions. We will call the same things, female, and here we will change the direction. So I think this should work. Let's go back to our browser and see. Let's refresh and see if our morphing works. Okay, so as we can see that now our morphing is working. And when we click on male, it changes to male, and when we click on female, it changes to female. We also have to look into using function. So let's quickly revise what is an easing function. In the previous video, we already saw what is an easing function. So I will give you a very brief and short easing function. This is a quadratic easing and out function. As you can see its graph, it's very similar to a typical easing function, which starts slow, then rapidly progressive, and stops slow as well. So this function has two conditions. In between 0 to 0.5 value of t, this should be 2t squared, and in between this value, uh, 0.5 to 1, there this should be the value of t. So let's go back to coding and let's code this part. So we would just write a function called easeInOutQuad, and let me quickly write that function. So this is a function. This is a one-liner which implements all the formula. So this is 2t squared in case t is less than 1, and 1 the same formula which is implemented in which is shown. And if you want to go into depth, we can explore this in further videos. But for our purposes, this is good enough. And how would we implement this easing function? We would just come here, and when we are calculating the progress, we would just make another variable called ease, and we would call easeInOutQuad. So this is our ease function. We would just pass the variable here in our ease function, easeInOutQuad, and Instead of T, we would just replace it by ease. So it will make sure that we have incorporated our ease function here. So let's get back to our HTML and refresh, and let's see. So there is a subtle difference. We might not be able to observe it, but when you're implementing it on your own browser, you might be able to see this. The speed of animation at starting and ending is has changed a little bit. So this is pretty much it for our series. We have successfully been able to use SVGs and morphing in vanilla JavaScript, and we have been able to kind of similarly implement the effect which we saw on Adobe XD. And the good thing is we are also interpolating the color, which wasn't available in Adobe XD for some reason. So we can see that this is a smooth transition between these two shapes and color as well. So if you have any questions, please feel free to ask. And thanks for watching and take care, and we will meet next time.